The next type of queue is DQs. DQ is nothing but a double-ended queue. A double-ended queue is a data structure which allows insertion and deletion of elements at both ends, in both the front end as well as the rear end. This property makes this DQ more versatile compared to a standard queue, which only allows operations at one end. And there are two variants of double-ended queue, DQ. One is input restricted queue and another one is output restricted queue. When it comes to input restricted DQ, in this DQ insertions can be done only at one of the ends, while insertions can be done from both the end. When it comes to output restricted, deletion can be done only at one end and insertions can be done at both the ends. These are the two variants of DQ. And normally this can be implemented, this DQ structure can be implemented using either a circular array or circular linked list. This can be implemented, but in the pseudocode I would have implemented it using circular array, and you can proceed it with using circular linked list also. And normally in a normal queue, in any circular queue, in normal queue we used only two pointers, one is front and another one is rear. Why? Because only at the front end deletions can be done and only at the rear end the insertions can be done. When it comes to this type DQ, both insertions and deletions can be performed at both the ends. So instead of using the front pointer and rear pointer, I am going to use the left pointer and right pointer, which means at the left end both insertions and deletions can be done, and also at the right end both insertions and deletions can be done. Let's discuss insertion, pseudocode for performing insertion operation at both the ends, right end as well as the left end. Let me discuss how to perform insertion at the right end first, and these are the scenarios, different scenarios we would face while performing insertions at the right end. 4 different scenarios, and let's start writing the pseudocode. We are going to write the pseudocode to perform insertion operation at right. The very first thing is you have to check, since you want to perform an insertion, I am going to use circular array here. You have to check for the overflow condition. The overflow condition here is, as we all know, in a normal circular array, in a circular queue, the overflow condition is going to be if left equals to 0 and right equals to max minus 1, or one more condition is there, full condition is if left is equals to right plus 1, which means this is an array and this is my right and this is my left. If it is next to next in a contiguous location, it means that it is overflow only. So the overflow condition is when the left is equals to 0, check queue number 1. When the left is pointing 0 and right is pointing max minus 1, it is overflow. And also when left is equals to right plus 1 is also overflow. When it occurs next to next, the left pointer and the right pointer, that also is overflow. You can work on the queue and check. When the left is equals to right plus 1, it's overflow condition only. So these are the two conditions to check for overflow. If these two conditions are satisfied, print overflow. Else check the next condition, check queue number 2, example 2. If the queue is empty, if the element which you want to insert is going to be the very first element, check if left equals to right equals to minus 1, which means if the queue is empty, the element which you are going to insert is going to act as the very first element. Set left equals to 0, also right equals to 0. Let me write like this, set left equals to right equals to 0, which means left and right would be pointing, both left and right would be pointing the 0th position, and in the place of let me write here, in the place of, since it's DQ, I'll write DQ of, since I want to perform insertion at the right end, in the place of right I am going to place the value which I want to insert. The value which I want to insert is 20. So in the place of DQ right, I can insert the new value which I want to insert if left equal to right equals to -1. Check example number 2. Yes, left equals to -1, right equals to -1. If so, set left and right equals to 0, which means both left and right would be pointing the 0th index. And now in the place of, since I want to perform insertion at the right end, at the place of right, DQ of right, I can write the new value which I want to insert, which is 20, right? This is one condition. This is the second condition. If not overflow, the very first condition which you need to check is whether the queue is empty and the element which you want to which you are going to insert is going to act as a very first element. Else the next condition is, if, since I am implementing it using circular array, check if right equals to max minus 1. If right equals to max minus 1, check example 3, Q number 3. Yes, my right is max minus 1. I want to perform insertion at the right end only. Since right is max minus 1, as a next step, I am supposed to increment my right to 0, and now in the place of, I am going to set right equals to 0, and now in the place of right, I can insert the new value which I want to insert, which is 20, right? So, if right is equals to max minus 1, set your right equals to, set your right equals to 0, and in the place of right, DQ of right, you can write the value which you want to insert. Else the normal scenario, look at Q number 4, which is a normal scenario. Since I want to perform insertion at the right end, simply I can increment my right here, right equals to right plus 1. So now my right would be pointing here, and in the place of right I can insert my new value which is 20. So set right equals to right plus 1, and in the place of right insert a new value and end the pseudocode. This is how we are supposed to perform insertion at the right. Let me explain again. The very first condition you need to check is, I want to perform insertion at the right end. So the condition is check for overflow. To check for overflow, this is the condition: if left equals to 0 and right equals to max minus 1, or if left is equals to right plus 1. These two are the conditions. If any one of these conditions are getting satisfied, you can print directly overflow, which means insertion cannot be performed in a queue. Why? Because the queue is completely full. Else check for the condition whether your queue is empty, which means the queue is completely empty. The element which I am going to insert is going to be the very first element in the queue. So check for this condition to check whether the queue is empty. Left is equals to right equals to 1 means the queue is completely empty. Look at the second example, and set left equal to right equals to 0, and now in the place of right, since I want to perform insertion at the right end, it would go to this and it would come out of the if statement, and in the place of right it would insert the new value which I want to insert. Otherwise the second condition is, if right and left is not equals to -1, which means the queue is not empty, already there are elements in the list. Now check for the next condition, if right equals to max minus 1. If right is equals to max minus 1, the next right should be the first position, the first index, right? If right equals to max minus 1, you cannot increment the right. Why? Because this is going to be the last position. So set your right equals to 0, and in the place of right now you can perform insertion. Else the normal scenario only, these two fails means it is a normal scenario, no overflow. These two conditions also are getting failed, which means it is a normal scenario. Simply you can keep incrementing your right pointer, and in the place of right you can keep inserting the value which you want to insert. Again the next value, if you want to insert, again you insert a new value. Check for overflow condition, it fails. Left and right equals to -1, again it fails. Right equal to max minus 1, again it fails. And simply increment your right to the next position here and insert a new value. Suppose I want to insert a new value 25, 25 can be inserted. Now again I want to insert a new value 30. Check now whether left equal to 0, right equals to max minus 1. No, right is max minus 1, but my left is not equals to 0, so overflow condition doesn't occur here. And check whether left equal to right equals to -1. No, which means there are already elements in the queue. Check whether your right equals to max minus 1. Yes, my right is equals to max minus 1. If so, you have to set your right equals to 0. Now right would come here. In the place of right, you can set right equals to 0. In the place of right, you can insert a new value which is 30, right? and then again I want to perform insertion. Check for overflow condition, whether your left equal to 0, right equals to max minus 1, no. Check for one more condition, because we have two conditions to check whether the queue is full, right. Now check whether left equal to right plus 1, no, left, yes, left is equal to right plus 1. If you check, right is 0 and left is 1, which means it is overflow condition only. If you check, the queue is completely full and left is right plus 1 only, it is overflow condition, which means insertion cannot be performed anymore. The pseudocode would end, it would completely come out of the loop, and you can come out of the conditions and it would end the pseudocode. Hope it is very clear how to perform insertion at the right end in a DEQUE. Now the next step is performing insertion at the left. Same pseudocode only. Let me explain. Few changes I am going to make here. Let me explain. Okay, when it comes to, I am going to change this same to perform insertion at the left. Now I want to perform insertion at the left. The condition, the overflow condition is going to be same only. The same condition, if left equals to 0, right equals to max minus 1, or if left is pointing right plus 1th position, it is overflow only. Same condition applies even to perform insertion at the left end also. And also this, you have to check if it is not overflow, which means there are spaces left, insertions can be performed, right. Now again, to check for whether the queue is empty and the element which you are going to insert is going to be the first element, again these conditions are going to be same only. If left equal to right equals to minus 1 means set left equal to right equals to 0, and in the place of left, you can, in the place of left, because I want to perform insertion at the left end, so instead of specifying right, you can specify it as left. In the place of left, you can set left equal to right equals to 0, and then it would come out of it. In the place of left, it would insert the value which you want to insert, the new value which you want to insert. Suppose new value 25 I want to insert, that would be inserted. Else check for the next condition. If instead of checking the right end, we are supposed to check the left end. Let me write one example. Let me make one queue example here to explain the second condition. Since I want to perform insertion at the left end, not at the right end, imagine this queue, and the condition here is, instead of giving right equals to max minus 1, here I am going to write if left equals to 0, I am going to set left equals to max minus 1. Let me explain. Since I want to perform insertion at the left end, I reached this extreme, the left extreme has been reached. I cannot insert any more element at the left end, because this is going to be the last element at the left end, right. So no more insertions cannot be performed when your left is equals to 0. In such case, you are supposed to shift your left pointer to max minus 1. This is max minus 1, right. So here it can be shifted, and now the left pointer would be pointing here, and in the place of left you can insert a new value which you want to insert, that is 25. Hope it is clear. Since I want to perform insertion at the left end, I am supposed to check only at the left end, because only at the left end I am supposed to perform insertion. So if I check, my left is pointing 0, which means left has reached this extreme. When it comes to right end, you will keep incrementing the right and you will be inserting new elements. When it comes to insertion at the left, you will keep decrementing the left pointer and you will insert it in the new positions like this, right. So now if you check, my left pointer is pointing this extreme. right? So no more elements, new elements can be performed here because there are no more spaces left after this extreme, right? So if the left is pointing the left extreme, which is 0, you are supposed to shift your left to max minus 1. So I am shifting my left in the next iteration to max minus 1. So now my left would be pointing the max minus 1. Now in the place of left you can insert a new value. Now again I want to insert a new value, which is 30. In such scenario, which is a normal scenario, it would come to the else part, and in the else part simply you can write, instead of writing right equal to right plus 1, you can write left equals to left equal to left minus 1, and you can perform insertion. Check again, I want to insert a new value 30. Check for the first condition whether it is overflow condition, no, and check whether left and right equals to minus 1. Take this example, check whether left and right is pointing minus 1, no, this condition fails. Check for the next condition whether left is pointing 0, no, left is not pointing 0, right, left is pointing 5. So left is not pointing 0, this condition is also fails, which means go to the else part, since both of these condition fails, which means it is facing the normal scenario, the regular scenario. Simply decrement to the left. After decrementing the left, now the left would be pointing the next position. Before it was pointing 5, now the left would be pointing 4. After decrementing the pointer, decrementing the left, it would come out of if, and in the place of DEQUE left it would be inserting the new value, which is 30. Again you check for the, again I want to insert the new value 35. Check for overflow condition, it fails, yeah, and left and right is minus 1, no, left is pointing 4 and right is pointing 2, again this fails. And check for the next condition whether if left is pointing 0, no, left is not pointing 0, this condition is also fails, which means the regular scenario only. Simply decrement the left equals to left minus 1. After decrementing the left, my left would come here, right, left would be pointing 3, and now in the place of left, come out of if, in the place of left you can insert a new value 35. Now left is pointing 3 and right is pointing 2. Now again I want to insert a new value 40. Check for overflow condition whether left is equals to 0, right equals to max minus 1, no. Check for one more condition for overflow, left equal to right plus 1, yes, left is equals to right plus 1, which means it is overflow. If you look at the queue, yes, there are no spaces left to insert a new value, it shows overflow. So it would come out of the conditions and it would end, the pseudocode would end here. This is how we are supposed to perform insertion at the left. Hope it's clear how to perform insertion at the right end as well as at the left end. And in the next video, let me discuss how to perform deletion at the left end as well as at the right end. So only few modifications we are supposed to do. Only at this place and this place, last two conditions we changed, and also instead of writing left here, we wrote, instead of writing right, we wrote left here. So only at these three places we will be making the changes, and also here. If you want to perform some operations at the right, you have to specify right here. If it is at left, you have to specify left here. Only at few places we have to make changes. That's it. Thank you.